Intermediate system. Intermediate system is a routing protocol designed to move information efficiently within a computer network. A group of physically connected computers or similar devices. It accomplishes this by determining the best route for datagrams through packet-switched network. The protocol was defined in ISO IEC 10589-2002 as an international standard within the Open Systems Interconnection reference design. Though originally an ISO standard, the IETF republished the protocol in RFC 1142. RFC 1142 was reclassified as historic by RFC 7142 because it republished an ISO draft rather than the ISO standard, causing industry confusion as this has been called the de facto standard for large service provider network backbones. Description: is an interior gateway protocol, designed for use within an administrative domain or network. This is in contrast to exterior gateway protocols, primarily border gateway protocol, which is used for routing between autonomous systems. Is a link-state routing protocol, operating by reliably flooding link-state information throughout the network of routers. Each IS router independently builds a database of the network's topology, aggregating the flooded network information. Like the OSPF protocol, IS uses Dijkstra's algorithm for computing the best path through the network. Packets are then forwarded, based on the computed ideal path, through the network to the destination. History: the IS protocol was developed by Digital Equipment Corporation as part of DCNet Phase 5. It was standardized by the ISO in 1992 as ISO 10589 for communication between network devices, which are termed intermediate systems by the ISO. The purpose of IS was to make possible the routing of datagrams using the ISO-developed OSI protocol stack called CLNS. IS was developed at roughly the same time that the Internet Engineering Task Force IETF was developing a similar protocol called OSPF. IS was later extended to support routing of datagrams in the Internet Protocol, the network layer protocol of the global Internet. This version of the IS routing protocol was then called Integrated IS comparison with OSPF. Both IS and open shortest path first to link state protocols, and both use the same Dijkstra algorithm for computing the best path through the network. As a result, they are conceptually similar. Both support variable length subnet masks, can use multicast to discover neighboring routers using hello packets, and can support authentication of routing updates. While OSPF was natively built to route IP and is itself a Layer 3 protocol that runs on top of IP, IS is an OSI Layer 2 protocol. It is at the same layer as connectionless network protocol. The widespread adoption of IP may have contributed to OSPF's popularity. IS does not use IP to carry routing information messages. OSPF version 2, on the other hand, was designed for IPv4. IS is neutral regarding the type of network addresses for which it can route. This allowed IS to be easily used to support IPv6. To operate with IPv6 networks, the OSPF protocol was rewritten in OSPF v3. IS routers build a topological representation of the network. This map indicates the subnets which each IS router can reach, and the lowest cost path to a subnet is used to forward traffic. IS differs from OSPF in the way that areas are defined and routed between IS routers are designated as being Level 1, Level 2, or Level 1 to 2. Routing information is exchanged between Level 1 routers and other Level 1 routers of the same area, and Level 2 routers can only form relationships and exchange information with other Level 2 routers. Level 1 to 2 routers exchange information with both levels and are used to connect the inter-area routers with the intra-area routers. In OSPF, areas are delineated on the interface such that an area border router is actually in two or more areas at once, effectively creating the borders between areas inside the ABR, whereas in IS area borders are in between routers, designated as Level 2 or Level 1 to 2. The result is that an IS router is only ever a part of a single area. IS also does not require Area 0 to be the backbone area through which all inter-area traffic must pass. The logical view is that OSPF creates something of a spider web, a star topology of many areas all attached directly to Area 0, and IS by contrast creates a logical topology of a backbone of Level 2 routers with branches of Level 1 to 2 and Level 1 routers forming the individual areas. IS also differs from OSPF in the methods by which it reliably floods topology and topology change information through the network. However, the basic concepts are similar. OSPF has a larger set of extensions and optional features specified in the protocol standards. However, IS is easier to expand. Its use of type-length value data allows engineers to implement support for new techniques without redesigning the protocol. For example, in order to support IPv6, the IS protocol was extended to support a few additional TLVs, whereas OSPF required a new protocol draft. In addition to that, IS is less chatty, and can scale to support larger networks. Given the same set of resources, IS can support more routers in an area than OSPF. This has contributed to IS as an ISP scale protocol. The TCP/IP implementation, known as Integrated IS or Dual IS, is described in RFC 1195. Other uses. IS is also used as a control plane for IEEE 802.1aq shortest path bridging. SPB allows for shortest path forwarding in an Ethernet mesh network context utilizing multiple equal-cost paths. This permits SPB to support large Layer 2 topologies, with fast convergence and improved use of the mesh topology. Combined with this is single-point provisioning for logical connectivity membership. IS is therefore augmented with a small number of TLVs and sub-TLVs and supports two Ethernet encapsulating data paths. 802.1 add provider bridges and 802.1 are provider backbone bridges. SPB requires no state machine or other substantive changes to IS and simply requires a new network layer protocol identifier and set of TLVs. This extension to IS is defined in the IETF proposed standard RFC 6329. Related protocols. Fabric shortest path first. IEEE 802.1aq shortest path bridging. Transparent interconnect of lots of links.